So in this video, we're going to focus on one particular method of solving a system of linear equations, and that's by graphing. So if you watched the previous video, you should know that the intersection of the graphs of equations represents the solution to that system of equations. So when we're graphing these, that's what we're going to be looking for today. We're going to be trying to find intersections. So I want you to think about this. How many intersections can actually exist between two lines? Now you have seen an example of this before. Obviously you can have two lines intersect one place. But is there any weird stuff, any funky stuff that could happen with intersections? I want you to pause and think about that for a moment. All right, so hopefully now you've thought about not having any intersections at all, right? So what if there were no intersections? Because the lines were parallel. I'm just going to draw a quick little sketch of what that would look like. Right, the lines are parallel. What would that mean if there are no intersections? Well, if there are no intersections and intersections are solutions, that would mean that this has no solution. Right? This is a special case here. So let's do an example of where that happens. I'm already telling you that the answer to this is no solution. If we were to graph these two lines, we have to know what form they are in. So we are looking at y equals mx plus b form. Right? They're both in that same form. Remember that m is our slope and b is our y-intercept. So let's go line by line here. I'm going to use a red line for this, and I'm going to start at the y-intercept. So -3 on the y-axis. Slope of 1/2 means we're going to go up 1 over 2. Up 1 over 2. When we are solving systems graphically, we want to get as many points on this graph as we possibly can. And then we'll draw that in. All right. Now let's work on the second line here. So we have a +2 for the b. So our intercept is right here at 2 on the y-axis. And we have the same exact slope. So we're going to go up 1 over 2. Up 1 over 2. Right, and we can continue doing that. And the other direction as well. Right, and now we can see that those lines are parallel. Think about what makes those lines parallel. What is the special feature that they both have in common? And I hope you've recognized that it is their slope, right? The slope controls how steep these lines are. So if they have the same slope, they don't have any intersections because they are parallel. And I'm just going to jot that down. All right, so this had no solution, no intersections. Okay. Let's do the example that hopefully is obvious. What happens if we have one intersection? Those lines are not parallel. Right, looks something like that. Then we're going to have one solution. Okay, so let's see what we can do with these. Ooh, those are not in y equals mx plus b form. It looks like this is in standard form. And this one is in point slope form. So for standard form, this is where we want to find the x and y intercepts. So to find the x-intercept, I'm going to cover up the 3y. That's the same thing as plugging in 0 for this. And I'm going to solve the equation 2x equals 12. And I get 6. There's my x-intercept. And now I'm going to plug in 0 for x, or cover up the 2x, and solve the equation 3y equals 12. Divide both sides by 3, and we get y equals 4. So here's my y-axis. There's 4. And we will graph. All right. One line down, one to go. And do black this time. Okay, point slope form. This is where our slope is. And our point comes from these two values right here. So my point will be 1, -2. 1, -2. There we go. And we're doing a slope of 2. So up 2 over 1, up 2 over 1. Looks like we found our intersection there. Up 2 over 1. I'm just going to keep going. There we go. And we will draw that one in. And you'll notice that when these intersected, it looks like it intersects at a nice point. Sometimes with graphs, we're not too sure, right? Graphs, they're not always exact. All right, so what would our solution be for this problem? Our solution is the intersection. So the intersection would be at 3, 2. Our x is 3 and our y is 2. All right, so I have this third example, and I'm not sure if you've considered this, but we could have more than one intersection from two lines. And I'm not talking about making them into curves. I'm saying they're going to stay lines. But what if there were infinite intersections? Right? How would that happen? Well, you'd have to have a line on top of another line. They'd have to be the same line. And if that's the case, then I guess we have infinite solutions. So how are we going to write down what all of those solutions are, right? We got to come back to that question. We know that that's going to be the situation here. So let's get our graphs going and just see how that looks. Okay, so we know that when we graph these, we should get the same line, but let's take a look. The first one, that is in our y equals mx plus b form from back here, right? Our slope is 1, and our y-intercept is -4. I'm going to do this line in blue. Here's -4. And our slope of 1, we go up 1 over 1, up 1 over 1. And we do that there, and the other way. And we draw our line. And our next one, I'm going to do in pink. That's standard form. Remember standard form over here where I plugged in 0 for x and solved for y, plugged in 0 for y and solved for x? So we're back to that. So let's plug in 0 for y here, and we're going to solve 2x equals 8. So I get x equals 4. And then we're going to plug in 0 for x, so -2y equals 8 is still there. We divide that by -2, and we get y equals -4. And look at that. We get the exact same intercepts. right? So we have the same line there. Okay, so how are we going to write down all of these answers? Well, there's no way we're going to write down infinite things, right? And if you wrote down infinite solutions, you'd be answering how many solutions there are. But that's not the question when we're solving systems. We want to know, what are the solutions? Okay, so we're going to say all points on the line. All of the points on the line are the solutions, okay? If Delta Math asks you about this, right, they might say how many solutions there are. Yeah, then it makes sense to say infinite solutions. But if somebody asked me what are the solutions, I would say it's all the points on the line, right? I can't say all of them. I could give you the equation of the line, but that's the best that we can do for that. So we have these three situations that could happen. Your job is to remember how to graph slope-intercept form, standard form, and point-slope form so that you're able to get these pictures. Good luck with your practice.